we're starting a little mini unit on something called simulations. And we need to talk for a minute about why simulations. You guys were supposed to read chapter 10. And I want to be, but let's think about it this way. Let's say we want to figure out whether or not a car has a good, the windshield of a car breaks. Remember how, do you guys remember, anyone watch Downton Abbey? Anybody? I'm the only person in this class that watches Downton Abbey. I'm old, that's all right. But in Downton Abbey, the guy dies because he had to go through the windshield. Anyway, back in the olden days, the windshield of cars didn't have any kind of special glass, and people were their heads got cut off all the time. And so, what if we wanted to test some new glass in our cars? And I decide to put Noelle in one of the old cars, and I decide to put Kika in one of the new cars, and we're gonna just test it and see what happens. Okay? All right, so we're gonna start. Kika, you push go. Noelle, you push go, and we just hope for the best. Okay? What do you guys think? Good idea? What's wrong with that? Well, we know that we are probably going to hurt someone because historically that's happened, right? So we have to do something like a simulation, right? Where we're not going to hurt people. Okay, we're going to simulate that experience. You guys have seen the commercials with crash test dummies. You guys know that that's a simulation of a car accident. There are all kinds of commercials about it. That's one type of example. Give me some of the reasons that you read about why you should do a simulation. Why a simulation? Why are they necessary? Besides, obviously, the example of we don't want to kill anyone. We want to save people. That's the point. Anything that you read about? Why a simulation? Why are simulations effective? Davis? Okay. So time is one of the big things, okay? It's going to save time if we can simulate a particular thing, especially when we talk about something that we're going to study over a long period of time. If we can simulate it in a short time span, then it will save that. Yes? Money is the big one, okay? We're a capitalistic society. We're trying to save that money, and simulations do, in fact, do that because you're simulating an experience as opposed to actually having it, okay? So there's a whole research group that's dedicated to simulations and just doing simulations and almost any kind of manufacturing that happens, okay? So we're going to do a little kind of snippet with it, not spend a whole lot of time with it, but they do appear on the AP exam, so they're pretty important. So let's think about this, and this is a little tiny. I'm not sure why it's so little. But anyway, can you read that in the back? Darker color. You're asking a lot of. And make it color. Better? You're like, not really. Okay. Why is this so terrible? Why isn't? All right, well.
Wait, tap it and then so it can get out. Yeah. No, okay.
Tap the word.
All right, I'm just going to talk. So we're going to toss a coin 10 times, okay? And we're trying to figure out the likelihood of, just going to try to make it, I don't know how big that's going to be. Oh, that's tinier. Aha. Better? All right, we're going to toss a coin 10 times. We want to think about the likelihood of a run of at least 3 consecutive heads or 3 consecutive tails, okay? So this is just kind of like a, would it be hard to do? I'll ask that part. Do you have coins? If you have a coin in your pocket, in your purse, get one out. Get out. Right now. No one has a coin? Get a coin out. Cameron, get a coin out. Anyone got a coin at all? What could we use in place of a coin if we didn't have a coin? Any two-sided anything. Would you agree? Okay. Anything two-sided that you can flip? How about your eraser? That pink eraser. Okay. You can flip it. long as it's not going to end on its tip like this. Okay, anything two-sided. I want you to go ahead and toss it 10 times and record what you get. Okay, so I'm going to pause the recording. Let's go ahead and everyone do their own trial. Go ahead and toss it and let's see what happens. I hate to say it, but you guys are doing something incorrect as I'm coming around. I'm not asking for a tally. What is a word in this problem that's important? Consecutive. So I am looking for a string of 10 letters, HT, HTT, HT, HT, whatever it happens to be. I'm not looking for a tally. I'm looking for consecutive. So let's rethink that. That's an important word because that's important in how we're going to collect our information. So if you need to restart, that's fine. And let's go ahead and think about anybody. So everyone go around to each table and tell me, you wrote your HT, whatever. Anybody raise your hand. Well, first of all, raise your hand if you did the trial so I know how many. How many of you totally did it? Just did the trial. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did everybody do it? That's okay, but as long as everybody has something in front of their hands, right? Okay, so we'll say 27 total people, right? Did the trial. Slow. How many of you had consecutive, 3 consecutive heads or 3 consecutive tails? And everybody in the group, wow, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23? How many of you did not have consecutive heads? That's okay. Either or. Only one person did not. So I don't see that. Is it okay if you have like 4? Yeah, it doesn't at least. It said say at least. Of at least, right? So it could be 3 or 4, right? Okay. And that's not that many trials, right? And it took us a while to get that, to flip the coin, okay? What if I asked you to toss the coin 100 times or 1,000 times? We'd be here till like Friday. Would you agree? So there's got to be a different way to be able to simulate this. And actually, a coin toss sometimes is used as a simulation, but there are ways to simulate the actual coin toss. Let's look at one of those examples, and one of those examples is using a calculator. Your book talked about this last time, so if you have your calculator, get it out for me. And we're going to simulate a coin toss. So anytime you're looking at simulating something, you're going to look at the number of outcomes. In a coin toss, how many outcomes are there? 2. So we need to create a situation on our calculator in which we have 2 outcomes. So there's only 2 outcomes here. I'm just trying to minimize that. There we go. All right, better. So 2 outcomes. There is a random integer function on the calculator that will randomly create integers for you, okay? And it'll actually do 10 at a time. Oh, didn't we create a list of 10 HT, whatever? So we need a string of 10 outcomes. So we can pick something that has 2 outcomes. Zeros and ones, does that sound okay for you guys? Just using those 2 numbers, just zeros and ones. You can pick any 2 numbers, I don't care. 3s and 4s, 5s and 6s, I don't care. But normally we use zeros and ones, called binary. You might have heard that term before. I can never see this calculator because it's so blurry close up. But we're going to find the random integer function on your calculator, and I'm going to use a real calculator because it's easier for me to see where it is. But if you go to math, probability, okay, so math, and then arrow over to PRB, you'll see option 5, okay? And option 5 is the random integer function. Now again, I had the old operating system. I learned last week that I can get our, was it this week? Monday, that the new operating system exists for the online calculator, so I'm going to update mine soon. Rand-int. Yours, does it come up with the new operating system the exact same way? No, I didn't. You had the old one. So the new one says upper, lower, and paste. Do you see that on some of your calculators? Okay, upper, lower. So the upper, the lower, upper. You see what I see? Okay, I'm not sure why yours says that. We're going to do we're going to go from 0. We want 0 and 1. So we're doing zeros and ones, and we want a string of 10 of them. So your n is going to be 10. Those would be the other operating system. You're telling the commas are right above the 7. So you're telling the calculator, I want a string of 10 zeros and ones. Before I hit enter, I have to decide which ones are the heads and which ones are the tails. So you have to make that decision first. You have to assign what they are. Does that make sense? So what do you want? Heads of zeros? Perfect. So we're going to assign heads to be zeros and tails to be ones. Okay? And we're going to go ahead and hit enter. And it's going to give us a string of zeros and ones. And we're going to count this. This is one trial. And we're going to need to do many trials to see what's happening. So I'm just going to go up here and I'm going to arrow over to look. What am I looking for? 3 consecutive. And I don't see 3 consecutive here. If I hit enter, I didn't, did I? If I hit enter again, I'll just do it again. And it will do a different set. I see 3 consecutives. I'm just going to hit enter a couple of times. Ooh, that's definitely. And let's arrow over. No. So I have yes, no, no, yes. 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 So you get the idea, okay? And these are, each one of these enters, each one of these lines on my calculator counts as one trial of the series of flips, okay? So we have similar types of outcomes. Most of them had 3 consecutives. Would you agree? Okay? So similar outcomes here. Now, couldn't I just hit this calculator enter 100 times? Because it's asking me to flip it 100 times, right? Or 100 trials. Would you agree? So it's an easier thing to do. So using technology is one way that we can do a simulation of an activity or a simulation of something. And that's most likely, well, not most likely, but it's one of the ways to do it. What's the other way that you read about in your textbook? Has something to do with a piece of paper with a series of numbers on it. What was it called? Random number table. You should have read about that, okay? And there is an example of a random number table in the back of your textbook, all right? And we can look at that here in a few minutes. Well, this is actually what it looks like, just a random number table, okay? And we can use that. Now, if we had a random number table in terms of the flips of a coin, how could, the calculator was pretty easy. Zeros and ones, so just we had a 50-50 shot. We knew what we were doing. How can I do this with the coin? How is it different, first of all? I have all the digits, 0 through 10. So there's a couple of ways I could simulate this. Let's talk about one of the ways. One of the ways could be, I could still just use zeros and ones. And then what would I do with everything else? Ignore it. That's one way to do it. But I'd be ignoring an awful lot of numbers. Wouldn't you agree? So maybe there's a way where I could use most of the numbers or actually use all of them. What's another way to assign the 50% probability to the digits? Because that's the key to today, is how do I assign a probability? We're trying to flip a coin. You got a 50-50 shot at getting a head and a 50-50 shot at getting a tail. I want to take these digits and assign that 50%. Paige, you got an idea? Turn up. Yes, exactly. Okay, so we're going to say 0 to 4 is going, you said heads, right? Page. Heads. Heads. And then 5 through 9 could be tails. Okay. Isn't that 50% of the single digits? 50% of the single digits. Well, all right then. So let's see what we got. I'm just going to create the first 10. And often I will tell you that in a random number table, they are grouped by 5s. So that's going to be one trial. Okay? And then we'll go, and I'll just do them in different colors so you can see. But just so you know that each one of those series is a trial. Okay, it's just a group of 10. Because it said 10 flips, didn't I? What?
It's not like
What's on the bottom row?
oh wait.
They're 5
Never
digits in
mind,
each.
never mind.
They're 5 digits in each little group, right? So I did 2 of them to make 10. All right. So I'm just going to write down the first. So this is going to be trial 1. Let me write in different color. This will be trial 1. This will be trial 2, trial 3, trial 4. Are we okay with that? So in trial 1, let's just write what we have. We're looking for the trial 1. I'm just going to say we have heads, heads, heads. Well, that doesn't matter because we have 3 consecutive already. Would you agree? So that one works. Trial 2, now I'm looking at the green, and I have tails, heads, tails, heads, heads, tails, tails, heads, tails, heads. I don't have any 3 consecutive there. Would you agree? So no. And we can keep going. Are we okay with what I'm asking you to do here? Any questions? Because this is the basic one. They get more complicated. You okay? Yeah. Right. Okay. So, a simulation is used. We already kind of talked about this to save time and money, study situations that could be either dangerous to create in real life, like putting Noelle out there, going through a windshield like that, or just impractical, something we just can't physically do, but we want to at least simulate, and we're trying to simulate the outcomes is what we're trying to simulate, okay? These are the 5 steps to creating a simulation. So these are things, if you're going to write something down, this is what you should write down, okay? The 5 steps. The first one is to state the problem or describe the experiment, or really describe the simulation. It's not really an experiment. That's kind of a misnomer there. We're not sure what an experiment is yet. So I'm going to say simulation here. The fact that this is so slow behind me, it's making me crazy, but that's okay. So we're going to describe the simulation. Come on up, Kylie. I'm sorry, I moved everybody around. Be careful of that chair. It has a little crack in it. I don't want you to pinch your leg. Okay? So describe the simulation. So in our case, what is the simulation we're trying to do? We are simulating a coin toss with 10 flips. Would you agree? That's what we're simulating. Is that the example we did? So I'm just going to kind of write underneath it the 5 steps that we would do, okay? So for our example, we're going to simulate a coin toss with 10, oops, should I say the word 10? With 10 flips. All right, that's just what we're doing. Number 2, state the assumptions. What do we need to assume in this case? That the likelihood that each integer shows up is equally likely. That we have a fair coin. It's not bent. Heads is not going to come up more likely than tails would. Okay? So that each outcome has an equally likely probability. And that's almost always the thing we're going to assume, okay? I would say number 2 is probably a statement that we're always going to say, okay? So number 3, assign the digits. So we kind of already did that, but let's formalize it again for step 3. Paige, you said 0 to 4 was heads, and 5 to 9 was tails. We assign the digits that match our probability. And we're going to look at several other examples today where we're going to have to think about that, okay? But this is where you do it in step 3. Number 4, it says to go through the trials. So this is where you're going to put the outcomes of the trials, okay? So back here, this is where you're going to put this information, what I've written in red. Trial 1, this is what happened. Trial 2, this is what happened. Trial 3, this is what happened, etc. Okay? So I'm just going to leave that blank because we're not going to do it again, but this is where that would happen. And then step 5, you have to put your conclusion. The conclusion can be several things. It can be the likelihood of 3 consecutive heads is, according to our simulation, is equal to this probability. Didn't we get like 26 out of 27 in our class? Okay. I think the calculator had, I don't know, 4 out of 6 maybe? I'm not sure. Okay, so we'll just use the calculator one. We only did 6 trials, which is a no-no. So we should do more trials than that. 4 out of 6, so that would just be 2/3. So that's the probability. So it's 2/3 likely to get 3 consecutive heads or tails. Okay. The problem that I have with the calculator outcome, the one that we did quickly, is how many trials did we do? 6. We pushed the calculator and we entered it 6 times, right? Which is not really a lot. So this probability, how comfortable do you feel with its accuracy? Pretty comfortable? What would make you more comfortable with the answer or the conclusion that you're going to draw here? More trials. Absolutely. So sometimes you want to say that. Actually, most often you want to say that. The more trials, the more accurate the answer. And that happens here. If you're looking for a probability or a likelihood, the more trials you do something, the closer it's going to get to the actual true theoretical probability. You have to do the trial, you have to do the trials a lot. Your N or your sample size has to be large. But these are the 5 steps for any simulation. Okay? And there's going to be different kinds, and we're going to look at several of those today. Okay? Any questions about the steps? You sure? All right. So here's another, well, we already did this, I wrote it down. So, sorry, already did that. Let's look at another example. Okay, so here's another example. I think they changed, did they change the Tiger Woods example in the book when you read it? Because we have new books this year. It used to be about Tiger Woods. Is he still in the book? They got rid of him. All right. Gone. Get out. Get out of my book. All right, so I'm not sure what the new book's example was, but did it deal with cereal boxes at all? Still did. Who were the people on it? Like LeBron James came into picture. Was Serena Williams still there? LeBron James, who else? Was Serena. And who else? Danica Patrick. Nice. They updated it. Na 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 na. I hate Tiger Woods, whatever. No. He needs to keep it home. Okay, anyway. Wheaties cereal has come out with new pictures on the cover of their boxes. So I did a different one, a different example, because I'm a big college football fan. Okay? And I said this. Well, I'm a Virginia Tech fan, but, you know, it's alma mater, you know. It's all right. It's homeschool, it's all right. All right, so anyway, we have Penn State. My sister-in-law went to Penn State. They're coming back. Virginia Tech, I had a former student go to Alabama, a couple of them actually. Secret vote on Alabama, just out of curiosity, just in case you wanted my opinion. And then we have Texas, whose program needs help too. But anyway, so let's say that Wheaties had these are the four pictures that are on the boxes, and I want to collect all of them. I want to have one of each at least. Okay? And I'm given this information that 20%, Wheaties told me that 20% of the boxes contain Penn State. They must like Virginia Tech because 40% of them are Virginia Tech. We have 10 and 30. These percentages are very important for step 3 when I assign the digits. Would you agree? But let's, before we get, so we want to, how many boxes am I going to need to purchase? Notice it says on average. That's a key because we're going to be averaging something to get all of the pictures. Okay, so we're going to simulate this. We're going to use a random number table as practice, but you could also use your calculator. And let's figure out what we're going to do. So let's go through our steps. What is step 1? Describe it. So what am I going to do? What am I simulating? Okay, so I am going to do, what does a trial consist of? That's something you might want to add here on step 1. State the problem, describe the simulation. We should state here on next to number 1, describe what a trial is. Or what is a trial? What constitutes a trial? So what is a trial? Okay. 10 flips was a trial here. In our example, what's a trial? I'm going to purchase cereal boxes as many times until I get one of each. Does that make sense? So I'm going to simulate the purchase of cereal boxes. I don't like not being able to see what I'm typing. Cereal boxes until I get one of each. Do you see how this is different than the simulation we did with the coin flips? The coin flips, we were told to flip it 10 times, right? And a trial was just 10 things. How many numbers could be in a trial here? As many as I had to, till I got one of each kind. So you might have some trials that are very short, some trials that are very long. But it's important to understand that it's a different kind of trial. That's why you're describing that in number 1. Okay? What's step 2? State the assumptions, which is every number has an equally likely chance of getting picked. Okay? So every number has an equally likely chance of being selected. Okay, here's where the math comes in. Step 3. I have to assign digits. It's not hard. All right. Here's a hint. If you have if your percents end in a 0, you're going to use single digits. If your percents end in anything else, you're going to use double digits. So we have single digits right now because they end in a 0. That's kind of important, so I'm going to say it one more time. If your percents end in a 0, you're going to use single digits. If your percents end in anything else, you're going to use 2. Okay? I believe that your just checking example in the textbook was like 53% or something, wasn't it? It was an odd percent. It was not a percent that ended in a 0. So you had to simulate with 2 digits. Yes, ma'am. 10%, 15% would mean 2 digits.
So you mean like,
Any percent that ends in a 0, like 10, 20, 30, 40, 50, 60, 70, 80, 90.
yeah, I mean like, what do you mean? Yeah.
Okay, so in my random number table, which I'm going to pick and move down here, in my random number table, I'm not looking at one digit. I'm going to look at groups of 2. Like 41, 24, 86, 54, 11. You're going to look at 2-digit numbers, okay? And so that might happen for us if we have a percent that deals with anything other than a single digit, okay? So let's assign our numbers here. We're dealing with single digits. So what are our numbers are 0 through 9. 2, 3, 4, 5, 6, 7, 8, 9. 20% of them, yes, sir.
When you assign the digits, are you going to assign them in order of how they're listed there?
It doesn't matter, actually. I actually just do it that way just for my own linearity, but you don't have to. Okay? So 20%. There's 10 digits. How many of them would constitute 20%? 2. So you can pick any 2 you want. I'm just going to pick the first 2. Is it okay? So I'm going to pick 0 and 1. So I'm going to assign 0 and 1 to be what kind of box is 20%? Penn State. 0 and 1 is Penn State. So I've used those. And then 40% would be the next 4 digits. So the next 4 digits, 2, 3, 4, and 5, are going to be Virginia Tech. So 2 through 5 is going to be VT. And then who's going to be Alabama? Lonely old 6. Okay, there's Alabama. So 6 is going to be Alabama. And then our last one, 7, 8, 9, is 30%, 3 of them, and that's going to be Texas. Okay? So I'll just put it over here. 7 through 9 is going to be Texas. How are you guys feeling so far? We've stated the problem. We know what a trial is. We have our assign. And then what's step 4? Do the trials. Okay? Now, I want you to do 2 things. I'm going to erase I'm going to go back to my number table, and I'm just going to erase this so that we can start clean and use this. Okay? And I'm going to be looking for, however, until we get one. I'm just going to circle when we get the right one. We want a Texas, Virginia Tech, Alabama, and a Penn State, right? So, 4. What is that one? Who's 4? 4 is Virginia Tech. So I have a Virginia Tech in my first purchase. And then I have, what's number 1? Penn State. And then I have another Virginia Tech. I'm sorry, another Penn State, another Virginia Tech. 8's different. What's 8? That's Texas. And then 6. Holy cow. That's Alabama. Would you agree? How many numbers was that? It's kind of hard to see with all my circling, but I have 1. So I'm going to write those down. 4, 1, 2. Let me just, so hang on. 4, 1. I'll highlight it, make it better. So we can stop here at that 6. Would you agree? That's an entire trial. 4, 1, 2, 4, 8, 6. So I'm just going to write that down here. In number 4, trial 1 was, again, the digits were 4, 1, 2, 4, 8, 6. 4, 1, 2, 4, 8, 6. And what am I looking for in terms of what is the outcome of that trial? I'm looking the purchase of cereal boxes until it's really the number of purchases, isn't it? The number of purchases. So how many total boxes did I have to buy here? So my first trial outcome was 6. Because I had to buy 6 cereal boxes to get 1 of each kind. How do we feel so far? Okay? Let's look at what trial 2 would be. Notice what I'm doing. I'm using my number table. I'm marking it for my own sanity, but I'm also listing and writing out the outcome. Okay? I need you to do that for me. So let's go back and look at trial 2. I'm going to use a different color highlighter just so we know, and I'm looking to get 1 of each kind. 5 is going to be who? Tech. 4 is also Tech. So I still have Virginia Tech. I have Penn State, Texas. So I have everyone until I get what number? What am I looking for? Until I get a what? I need 6. I need that blessed Alabama. So I got to go until I get a 6, all the way to there. That's my next trial. Does that make sense? I had to go until I got one of each. I got to memorize all that. Oh, okay. All right, so 5411. Let's see if I can do this.
Oh, I have.
Oh, you have it? Oh, read it to me. Good job.
All right, so 5, 4,
Whoa,
1,
hang on. Doing it in the highlighter. Don't want to do that. So 5411.
9, 2, 9, 2, 3, 5, 7, 2, 7, 0, 9, 0, 7, 8, 7.
That was the next trial. How many digits is that? What's the outcome of trial 2? 20? That's a big difference, isn't it? That's okay. There's variation. There's going to be some variability amongst the trials. I expect that. How many trials should I do? Because it said, well, let's make sure we understand the question. The question asked in the problem, how many boxes will we need to purchase on average to get all the pictures? So how am I going to do that? So here's what I'm going to do. I'm going to pause the recording, and we'll go ahead. How many trials do you think I should do? Is 2 enough? No. 10? 20? 30? 50? Let's do 10. We'll do 10. I think 10 is reasonable. Okay, we'll do 10. So I'm going to pause the recording. I'm going to put the random number table up for you, and I want you to see if you can get 10 trials out of that digit, okay? So I'll pause before I set you off and do this on your own with the 10 trials. Could I use my calculator to do this? I could. The problem with using the calculator is that you're going to have to keep track of how many times you have to hit the enter button. It's not like I'm going to do a string of 10 numbers. I'm just going to do one at a time. And I'm just going to count until I get the number I want. Does that make sense? So you're just going to go and do your rand int, and it's going to be 0 to 9 because you're looking at all of the digits. Would you agree? And then if you just don't put another comma, just do 0, 9, and then don't put anything for your n, then it will just do one number at a time. Okay? So you can use your calculator. But go ahead and conduct all your trials. We stopped at trial 3, we'll just say trial 1 had 6, why don't we just do this? Hey, let's make a chart, shall we? And we're going to complete this chart. Well, it doesn't really need to be that big. Okay, so we're going to say trial number and then the outcome. Trial 1 had 6. Trial 2 had 20. Trial 3 had 6. I want you to do all 10. Okay, and I'll pause it and you guys finish it out for us. So why don't we go ahead and figure out what the outcomes were? How long did it take us to get to trial 4? How many digits? 8. How about trial 5? 20 again, holy cow. 6, 15, 7. Oh my. Was it that 6? Was it the pesky 6 that was trying to get hard out? Okay. How about number 8? Or trial 8? 8, 9. Ooh, and 10. All right. So there's the outcome of all of our trials. And again, we're just looking at our random number table until we get one of each of our kind. A little bit of a different scenario than what we did with the coin flip. Now, for number 5, or step 5 in our process here, and I'm just going to write it on this page, a little out of order, but that's okay. This would be number 4 because it's the outcome of all of our trials. Would you agree? Okay, that's step 4. Step 5, I'm looking for a conclusion. What conclusion can I make here? Well, what was the question asking again? Let's go back. The question says, how many boxes would we need to purchase on average to get all of the pictures? We should average the outcomes. That's exactly right. And I would like to see that calculation. So we're going to say the average, and you're going to say 6 plus 20 plus 6 plus 8, all divided by the number. We're just averaging them, right? Plus 20 plus 15, dot, dot, dot. Just show me the work. And the average was, it should be what? Divided by 10. 13.6? Don't tell me, I don't know. 13.3. Okay. So 13.3. Let's write it in context. What's my context here? What is 13.3 what? Boxes of cereal. And let's go ahead and make a sentence. I will need to purchase oh my, let's write it again. This smartboard is being silly. Let's make it write it a sentence. I will, yes, baby.
Why do they need to buy so many boxes when they can literally just look at the cover?
I agree. What if they're wrapped, or what if maybe it's a picture inside of them? I agree with you, Chris. You can look at the front, not purchase it. But let's say you're ordering it from Amazon, and you don't know what's going to come in the mail, right? Be hypothetical with me, would you? All right.
Is that going to be like a part, like a question, like some?
No trick question like that will ever happen. Okay. But that's, I mean, it's a good point, right? I will need to purchase on Amazon, where I don't know the cover before I buy it. Purchase on average 13.3 boxes of cereal before I get, or until I get, one of each. So conclusion should be a sentence in context. Don't just put 13.3. Okay? Put it in the context of the situation. Yeah, I just showed the work. I just didn't, I ran out of room, but you can do it. You know, show me what you did. You added them all up. You can just say, if you want to say it this way to make it easier, it's the sum of the outcomes. So we could say the sum of the outcomes divided by 10, right? That's what we did. It's the sum of all the outcomes divided by the total. Okay? How do you guys feel so far? Good? All right, we're going to do another little cereal box question. And this one you're going to do in groups at your table, but you're going to use something else. So let me pause this while I pass them out. So Nicole asked a very good question. If you're asked to use a random number table, will it be given to you? On a quiz or a test, absolutely. Okay? On a homework assignment, you're going to use the one in the back of the book. Now here's another question. Do you always start at the top of the random number table? You can randomly pick where you start. You could say, I'm going to assign rows and randomly pick number 10 and start there. You can do that too, but normally we start in the top left. All right, so here we have a Rice Krispies situation, okay? And in each box of Rice Krispies, we have a toy guitar. And there are 6 colors of these toy guitars that are available. And now they're inside the box, so I have to open the box to be able to see. So Chris's question is actually a valid one. And we want, and Emma Grace is all about the color red, and she has to have the red one. Okay. How many boxes is good old Gramps going to have to buy for her to get that red plastic guitar? So we want to try to simulate this. And it says, assuming Kellogg's is not trying to hoard any specific color, we're going to assume that they are equally distributed. There's the same number, the same percent of each color, okay? So we're going to simulate this, because I'm not going to go out and buy, for each trial, these boxes of cereal to figure out what's happening. I need to simulate the situation. So what do you think we should do? Now we're going to use a die. We are absolutely, I'm telling you, we're going to use a die, not a random number generator or calculator or table or anything. We're going to use a die this time. So I'm going to come by and give everybody a dice. I only have, you might have to share with a partner, okay? So because I only have so many dice, just your elbow partner, if you will just do that for me. But let's explain, let's go through the process here, okay? What's the step? If we're going to go step 1, 2, 3, 4, 5, let's do it on the back. What is step 1? On the back, turn it over. Let's state the problem. What's the problem that we're doing? Number 1, step 1, state the problem. What is it? We're going to simulate the purchase of cereal boxes until I get the red one. I'll come by and give more people dice. Just pass them out. Oops, sorry. Throwing things. I am. Anyone want their own? They don't want to share? All right. Step 2. What are my assumptions? This one's specific because this one we're going to use a dice for. So what do I have to assume about the dice? That it has 6 sides. It's a 6-sided dice, and that each side is equally likely of coming up. There's not like a curve on one of the sides or anything like that. So we're going to, step 2 in our case is going to be a 6-sided dice where every side is equally likely a chance to appear. Okay? Why do you think I chose a dice in this situation? How many outcomes are there? There's 6 outcomes. Would you agree? So I chose dice, a 6-sided dice, because there's 6 outcomes that come out on a dice. If there were 2 outcomes, I could use a coin. 6 outcomes, I can use this kind of a dice. Any other kinds of outcomes, we can use a calculator or a table for. Okay. So what's step 3? Assign each color an integer from 1 to 6. So let's do that together. We have 1 through 6. What do we want 1 to be? What colors are there? It says red is 4, but let's just make up colors. 1 is blue, 2 is green, 3 is yellow, 4 is red, because it told us it had to be red. 5 is pink, and 6 is going to be chartreuse. No, purple's fine. Okay. Okay, fine. 2 peas. I like chartreuse. Do you even know what color that is? It's like lime green.
I don't like that.
Shh. Orange. Fine. Teal. We could be all kinds of crazy things. Me too. Brown's like a tree trunk. Okay. So step 4 is the trials. So I'm going to pause because it's going to get loud. Because guess what? You're going to roll your die. And you're going to generate a table here. You're going to fill in your table with numbers. Fill up the whole table. You get a 1, put a 1. You get a 2, put a 2. You get a 3, get a 3. Just create your tables. And I'm going to stop. Once you finish, I want you to look at your outcome of your rolls and decide what trials you had and write the outcomes of those trials. So we said that we wanted to buy until we got that pink guitar. So the red guitar. And the red guitar was number 4. So I'm just going to go and circle all of my 4s. And that's going to be the number of trials, is it not, that I was able to conduct? If I wanted to do this on my calculator, couldn't I have just gone to randint? 1 to 6, hit enter until I got a 4 and counted the number of times I pressed enter. That would also work. Okay? But I'm going to write that. I'm just going to write the trial 1. Let's see. So we have trial 1. We'll say trial number, and then the number of outcomes. So, good grief. Trial 1 had 1, 2, 3, 4. My trial 1 had 5. Would you agree? It had to buy 5 boxes until I got my first red guitar. So this is trial 1. I'll highlight it in yellow so you know, but this is going to be trial 1, and it was 5. Look on yours and tell me what your outcome was. Yeah, this is exactly what I'm doing here. Trial number and then the number and then the outcomes. So you do yours as I do mine. My trial, I had to buy 5 for my first trial. My second trial, I had to buy 2 guitars. 2 guitars. You look at yours and decide. You're just going to write your outcomes. This is step 4 in your 5-step process. You're going to use your outcomes and figure out how many trials you were able to do. My next trial, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't count the last 4. Yeah, this is not, because on my chart, the last 4 don't really mean anything because it wasn't a complete trial. So these you don't count. My last trial ended here. Your last trial will end on your last 4 that appears. Okay? Then I had a 1. And then I had a 1, 2, 3, 4, 5, 6. Oops. 1 and a 6. Yep, I'm just gonna stop here just for my own sake. So the question says, for number 5 on the actual piece of paper that I handed you, said on average, how many boxes did it take to get the red one? So what am I going to do to make my conclusion? I'm going to show my calculation. I'm going to sum the outcomes. I just did 5 trials. I don't know however many trials you're going to have. But my outcomes are going to be 17, 18, 19. It's going to be 24 divided by 5, which is like 4.9. I don't know. I'm just going to use your calculator if you don't mind real quick. 4.8. What was your average? A little over 4? 4.2? 5.6? Give me some others. What were yours? What was your average? 12.7? Oh, 4.7. I was going to say, wow. You weren't able to do many trials if that was the case. Brianna, what was yours? 6.2. So you didn't get many 4s. Not as many as I did. Okay? So I have to, that's not enough for step 5. What else do I have to include? A conclusion. So we're going to say, on average, I need to purchase, in my example, about 4.8 cereal boxes to get the red guitar. Okay? So, because I want to pause the recording and get it to kind of come together before we leave today, I'm going to stop this. But part of your homework is, or part of what you're going to finish in class in the next 15 minutes is going to be number 6. So I want you to think about number 6, and we'll come together and talk about that next class. But you're going to finish this today. Your homework over the weekend is on is on your Excel, on the computer. Okay? I will provide an alternate textbook assignment if it becomes you have a computer issue or something like that. But we created Math Excel accounts last week, and I've assigned a homework assignment on simulations there for you. All right? So there are problems on Math Excel. If you log in, it'll be right in the middle there. And I took the other ones off so you wouldn't get confused. But it's chapter 10, and it's there. And again, I will provide an extra, like an alternate textbook assignment if you're having trouble logging into the online. But I'd like for us to try to get to practice doing that. Okay?